Hi. In our previous lesson, we were working on rearranging equations. We did that so we could go on to this next unit, which is problem solving with kinematics. So let's go back and revisit this whole idea of rearranging equations. So in the warm-up, you'll see we have the following problem. It says if the initial velocity of an object is 0, solve for t. One nice thing about zeros is that if you take 0 and multiply it by anything, you still get 0. So right here, our initial velocity is 0. That means 0 times t, this whole section here, we can cross out. So now we just have d equals 1/2 a times t squared. If we're going to solve this for t, we want to get everything to the other side of the equation. So I'm first going to multiply both sides by 2. And the 2's will cancel on the right. Now I have 2d equals a t squared. I still want to get t by itself, so I'm going to divide both sides by a. And when I divide both sides by a on the right-hand side cancels out. Now I have 2d over a equals t squared. Now I still want to get t by itself, so I'll take the square root of the left side. When I take the square root of the right side, this 2 goes away. So t simply equals the square root of 2d over a. Now let's go back to the kinematic equations. In the kinematic equations, we have 5 variables. We have vi, which is the initial velocity. We have vf, which is the final velocity. We have d, which is displacement. A, which is acceleration, and t, which is time. Sometimes we refer to this as VIF-DAT. VIF-DAT for all 5 variables. And those variables are found in these equations here. This set of equations are called the kinematic equations, and they all relate to motion. And each equation has 4 of the 5 variables. In the first case, there is no displacement. In the second equation, there is no acceleration. In the third equation, there is no final velocity. And in the fourth equation, there is no time. So when we are picking out an equation to use, we have to account for whatever's missing. So let's read this problem. It says you speed up with a uniform acceleration from 0 meters per second. So we know we have the initial velocity, 0 meters per second. To 30 meters per second. Well, 30 meters per second is the final velocity. In 5 seconds, that's the time. It says, how far have you gone? That's the distance. The only thing we don't have is the acceleration, so we're going to look for an equation that does not have acceleration. And that is this equation here, because there's no acceleration. So we would use this equation to solve this problem. Let's try a couple more. It says a plane is on a runway and it's accelerating from rest. That means the initial velocity is 0 meters per second because it's accelerating from rest. And it says the acceleration is 4.8 meters per second squared. If you're not sure what variable is being represented, look at the units. Meters per second squared will always be your acceleration. For 15 seconds, that's your time. And it says how long should the runway be, and that's going to be the distance. So this is what we're looking for, and what we don't have is the final velocity. So we won't have the final velocity. I look for the equation that does not have final velocity in it. It's this one right here, and lo and behold, we'll use this equation to solve this problem. Let's try another one. A boy leans over a cliff and drops a rock. If he drops a rock, the initial velocity of the rock is 0 meters per second. And he drops the rock from 65 meters above. That is the displacement, so 65 meters is the displacement. It says the acceleration is negative 10 meters per second squared. So we have an acceleration of negative 10 meters per second squared. And then it says how long is it in the air? So we're looking for the time. So again, I'm going to put a question mark here. Once again, we're missing the final velocity. Look for what's missing, the final velocity, and use that equation to solve the problem. Let's actually go through and solve a problem. To do this, we're going to use the less method, but we're going to add one more piece to it. So let's review. Less method means you're going to first list L, the known and unknown variables. Then you're going to write down your original equation. That's the E, LE. And then we're going to add this in here. Rearrange that equation. Then the S would be substitute into that rearranged equation. And then S, again, would be solve for the unknown. So let's go ahead and try this problem. A driver slams on the brakes and skids for 4 seconds. So we know we have 4 seconds as the time before coming to a stop. That means the final velocity is 0 meters per second. You go and measure the skid marks show a deceleration over 10 meters. So we know the displacement is 10 meters. What was the initial speed of the car? That's VI. Looks like we're missing acceleration. I find the equation where acceleration is missing, and this is the equation I'm going to use. Okay, so I'll show that on the next slide. Same problem. Here's the equation that we're going to use. Now, remember the final velocity here is 0. So that means this goes away, the VF. So now I simply have D equals 1/2 VI multiplied by T. It says what was the initial speed of the car? So we want to get everything but VI on the other side. So I'm going to multiply both sides by 2. When I do that, the 2 goes away on the right hand side, and I get 2D equals VI T. So now I want to get T on the other side. I'm going to divide both sides by T. And here my T will cancel, so that now my equation is simply 2D over T equals VI. That's my rearranged equation. So next, I'm going to take my rearranged equation shown here and just plug my numbers in. I'm going to take 2 times the distance, which is 10 meters, divide it by T, which is the time, 4 seconds, and what we get is 20 meters over 4 seconds. Divide that out, and you get 5 meters per second. And that's your final answer. So the last step we want to do is really show this in the less form. And that's what we see here. We have our original listing of the knowns and unknowns. We have the original equation we're using. We have the rearranged equation right here. We substitute with numbers and units. We get our final answer, including units. That's it for today, and good luck.